everyone. Thank you all for joining. Welcome to this week's In Rhythm Lightning Talk. I am your host tonight, Austin Michael Komatz, Head of Mobile Practices here at In Rhythm. We have some really exciting lightning talks in the upcoming weeks. Just a reminder, our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time. Each week, one of our practice area consultants share their knowledge on the newest cutting edge technologies in their industry. So this week, Jacob Jerrell from the Mobile Practice will be walking us through Kotlin Multiplatform Mobile and explaining some of the benefits and drawbacks of cross-platform technologies. So super excited to see what Jacob has in store for us here. So without further ado, Jacob, take it away.
All right. Thank you, Austin Michael. So yeah, today we're going to talk about Kotlin Multiplatform Mobile. I'm an iOS engineer within Rhythm, so it might strike you as kind of odd, but I did have the opportunity to work with Kotlin a bit, and after day one, kind of fell in love with it, and then KMM drew me in even further. So what is KMM? Simply put, it's an SDK for developing Android and iOS applications. It's developed by JetBrains. It has support from Google, and being open source, it receives contributions from thousands of developers. Furthermore, it supports a wide range of other targets aside from Android and iOS, including web, Windows, Linux, macOS, and tvOS. It's familiar. It supports CocoaPods, or you can also statically link the framework with an Xcode build phase and Gradle task. KTOR, which is an HTTP client, and Coin, which is for dependency injection, and a wide range of other frameworks have already adopted it. So it'll be comfortable with Android developers as well. And as we'll see, it allows you to easily share networking, business logic, and many other computations. So first question is, how does it work? So to start off, it's heavily modularized. They have a core common Kotlin framework with modules for lots of other targets. In Kotlin native, the framework bridges Kotlin's native types to the targeted platform's native types. So for example, Kotlin string is bridged to NS string, unit to void, and so on. Using expect and actual functions, it allows you to bring core platform functionality into your KMM library. So think of dispatchers, UUIDs, HTTP clients, and third-party frameworks in your native language. So we'll go on to talk about Objective-C interoperability. Kotlin native frameworks for iOS are created by generating Objective-C code. Interoperability is bidirectional, so Swift libraries can be used, but their APIs must be exported using the objc annotations. Pure Swift libraries are not yet supported. Documentation heavily hints that they may be in the future. And while experimental, async await support has been added. It could be removed in the future. So by default, Kotlin suspend functions are generated using completion handlers for iOS. To go on, the Kotlin Singleton pattern via object is made available using the familiar iOS Singleton pattern of creating a static shared variable. So expect an actual example. So in here, we've defined an expect class, which just establishes some basic information that the platform should provide. So the platform variable should tell you what device and version it is. We also need a coroutine dispatcher to do synchronous functions. And you can also provide an HTTP client, although Kotlin is, or KMM rather, is rather good at determining it for you at runtime. So that is purely optional of whether you want specific platform implementation of the HTTP client. So down below is the actual class, which would clearly be in a different file defined in your iOS main target of your KMM library. But in there, you would import like NS Foundation, preview UID. You would import UIKit to get the current device's system name and version. And then of course, just like Darwin to get like dispatch queue and everything. I've left some stuff out of here just for brevity. So let's see, to go on and see how we use it. In the comfort zone for iOS developers, it's actually pretty simple. After the KMM framework's been built and exported in Android Studio, you simply import the shared module, which is the name of it by default, and it gives you access to your public methods and classes, excuse me. So here you can see the get post method we defined in the module automatically gives us a completion handler with the response type and an optional error. Whenever the view loads, it will quickly display platform information, a random GUID, and call our local get post method, which updates the post body state variable and gives us some nice lorem ipsum. As far as Android is concerned, it's simple, but the platform is a bit pickier about lifecycle and scope. So we've implemented a view model to handle our library suspend function and provide some of the other data. But just as on the previous slide, it's fairly straightforward. It will display the information about the Android device, a random UUID from that platform, and after a few moments, we'll again get lorem ipsum from our API call. I do want to talk about some pros and cons before we look at an actual live example. So some pros: a single code base for models, API calls, business logic, and unit tests. The ability to specialize as a front-end developer, where one person or group is more focused on business logic and another is focused on UI and UX. To appeal to the business, this translates to save money, accelerated delivery across platforms, and developers, well, developing. You can do important features such as logging and analytics. They can be implemented to provide just extreme consistency and perhaps another area where money could be saved. So there are some cons, of course. Pure Swift is not supported. Like I said before, that could change. There is this experimental async await. They try very hard not to make breaking changes, but it's still very much an alpha, and that's reinforced throughout documentation and even at build time. And a good deal of configuration is required, as well as planning, just to set it up and ensure you get a smooth integration. So I've listed some useful links here, which is basically all of kotlinlang.org. Unlike documentation websites for some languages, I won't mention Swift. Ktor is also listed as the final one. It's a very robust HTTP client wrapper, as I refer to it, with full KMM support, both client and server side. So it's very interesting to play with, even if you're not using KMM. So I will go ahead and show actually in Android Studio what we have set up here. I've basically created a quick factory class, given the HTTP client with JSON configuration, given it a little bit of timeout to make sure everything happens in a timely manner and there's no fatal errors on the Android side. Otherwise, we've established the greeting and we're just calling into our platform, our expect class that we defined earlier, and asking for the details from there. And then this is our suspend function, which just gets a post from JSON placeholders posts endpoint by passing in the number. The return's implicit, so response.body will return a post, assuming the call works. See, we can look at this. I've kind of reduced this a bit from what I showed in the example. It just has the platform, and then
you're sitting in the
dispatcher. And let's see, as far as extending this and actually implementing it, so it's aptly named actual. We have an actual class platform, an actual constructor, and a whole bunch of actual values or variables and functions. So we've just used string interpolation here. We're using Android, OS build version, whatever the platform returns to us. And then dispatchers.main is our coroutine dispatcher. As for iOS, that's also defined in a Kotlin file. There's a bit more information here that I left out on one of the slides as for how to get to the coroutine dispatcher. And you can see here where we've imported UIKit, Darwin, and Foundation to get to the UUID functions. So I'll go ahead and run the Android app in an emulator over here, and we should quickly get the platform information as well as UUID. And then within a few moments, we've pulled down our lorem ipsum from the API request. And that there's no trick or secret to it. It's pretty much exactly what I displayed on the slides. It's very straightforward. We're instantiating a view model on create. So anytime it reloads, we'll get the same view model. Of course, based on the functions, we'll get a new UUID and all that stuff. And then we assign the values to our text views. Very straightforward and simple. If we felt super comfortable with ourselves, we could go ahead and develop the iOS app from within Android Studio, but it's going to be lacking, some auto completion and functionalities that we as iOS developers are used to on that side. So moving into Xcode, it's actually, as I said before, it's quite a bit simpler, just because it's not so picky about life cycles and how you arrange things. So I've created the skip post method, which calls into the library we instantiated in it. And this showcases our completion handler, which was generated for us. It gives us an optional error, and the response itself is also optional just for safety. It does bridge to Objective-C, so it has to maintain some agnosticism about that. So assuming that returns, we should get all the same information we saw before, except of course the UUID will be uniquely different from the one we saw in Android. So I'll go ahead and build that, which is fairly quick. I'm not hiding anything in here. The iOS app is just instantiating content view. And so that's really all there is to this implementation here. So it's detected we're using iOS 15.4. That's using our actual implementation from the KMM module. Gives us our UUID and of course the same lorem ipsum we saw over in Android. And really, that pretty well concludes the presentation and talk about this. I'd like to open it up if anybody has any questions or feels that I left anything out.